For this tutorial, I'm going to be starting from the beginning, looking at objects and classes. And although we quite often talk about object-oriented programming, this is going to start with the idea of a class. The first thing I need to do is define a class, and as I do that, I'm going to talk about what is a class and why do we have two words here? Why do we talk about objects and classes? So in this case, and in this series of tutorials, I'm actually going to be looking at a fraction class, and the fraction class is going to be my vision, my definition of what a fraction should look like, what will be useful to me. So when we talk about a class is a design, it is an idea, it is a blueprint. It's not an actual code construct that we can manipulate and set values to, not yet. What it is my idealized idea of what a fraction will look like. And I'm going to start off with an integer numerator and an integer denominator. So that's my fraction for now. Pretty mundane, fairly humble. You might notice, well, I've got a class here. So whenever you create a class, you want to save it in the same named file as the class name. So in this case, that's fraction. So I'm going to save this in something called fraction.java. I've already done that. I'll just save it again. Fraction.java for the fraction class. But this does not have a main method. That's going to be in my other file. That's going to be in my test fraction file. And that is because right now, this is just my blueprint for what a fraction will look like. If I actually want to work with a fraction, I have to create what's known as an instance of the class. And that, when we create an instance, that's an object. The thing that we create, the instance of the class, is called an object. And for that, I need to have a secondary program. Well, in this case, to test this at least, I need a secondary program. I'm going to call it test fraction. I'm going to save it as testfraction.java. Here you can see that familiar main method. And in this, I'm going to create my object. Now, just to put this into some perspective, I want to declare a couple of other variables. I'm going to declare an integer I. I'm going to declare an array of integers called array, which is new int, let's say 5 elements long. And I just want to compare these because the first one is a primitive data type. So this is saying I need a section of memory for something as big as an integer. And an integer is a well-defined entity, and so it's always the same size. That's why this declaration ends here. And I'm going to label it I. Now I'm saying I'm going to need a variable that will point to an array of integers. Notice that we don't specify the size of the integer array here. Here, this first half, we are declaring the variable. So we're saying I want a label called array, and I need array to be able to point to an array of integers. And then, because we don't know how much room in memory this is going to take, we use the keyword new, and that tells the compiler that I'm going to need some space in memory, and I'm about to tell you how much space I need. And so here, I specify how much space I need. In this case, I need the space for 5 integers, so that reserves enough room in memory for 5 integers. Now take a look at creating an instance from a class or creating an object. The object class is called fraction, so I want a new variable. So the variable is f, and that variable has to be able to reference a fraction class or a fraction object. But it doesn't exist in the RAM of the computer yet. I once again need to use the new keyword, fraction, open, close, round bracket. So now I am constructing, that's what this does. This is constructing space in memory, new space in memory, to hold something as big as a fraction. And how big is a fraction? It's defined by our class. So it's got to have enough room for a numerator and denominator, 2 integers, and then whatever other overhead might go along with being an object in Java. But most of the memory requirements are right there, 2 integers. Okay, so having said that, I've created this new fraction. So I'm going to get rid of this other clutter. And now I'm going to do some things with my new fraction. Well, now that I've got my fraction, I can actually manipulate it. For the fraction f, I can set the numerator to 2, and I can set the denominator to 3. And now I have actually filled in these values. These are known as the fields of the class. And so when I create the object with the new keyword, now these are the fields of that particular object. The object f has the values 2 and 3. I could create another fraction, call it g, new fraction, and I could fill in a different set of values for this one. Let's call this one 5 and 6. So even though f and g, they were both declared the same way, they were both objects created from the same class, the same blueprint, they both have numerators, they both have denominators, but because I have set their values uniquely, they are completely different in the sense that they are two distinct objects in memory, and they have different values associated with them. And I could perform other operations on these, but I don't need to do that for now. I've accomplished my goal. I've created a class, I've created my blueprint for fraction, and I have created a little program here to test my blueprint and to create a couple of instances of fractions and allow me to assign values to the fields. So that's it. That's your introduction to the idea of classes and objects.